Yeah, so the first page is graphing, go to the second page or third page, you'll see the worksheet inside the packet. Okay, so number one, describe the transformation that changed the graph of the first function into the graph of the second. So some of the transformations we can pull directly from looking at the equation, but we got to rewrite it, right? Because that phase shift isn't the true phase shift because that theta and that theta over 4 is not in the correct form. So let's go ahead and rewrite that function. Actually, we're a couple pages in, so it's like the third page in your package. We're going to do that. So -2 cosine bracket. That theta and that 4 needs to be separated. What can we do in front of theta here? 1/4, okay. You guys, if you're working ahead, that's great because you can check with the key on the next page. Now, because I took the step of pulling that 1/4 out, I need to make an adjustment. So how do I balance that 4 with this term here? I need a 4 somewhere. Where do I put the 4? Numerator, good. I got to balance it out. If it's in the denominator in the 4 with the 4, I need a numerator with the 4. So 4 times. So now everything is very clear, right? We have the A, we have the B, we have the C, we have the D. So let's talk about each of the characteristics here. The negative is going to do what? Yeah, reflect over the x-axis. The 2 is going to vertically stretch the graph by 2. The 1/4, that's the b value, right? 2 pi divided by 1/4, that's going to stretch that that period out from 2 pi to 8 pi. So it's going to be horizontal stretch by a factor of 1/4. Sorry, factor of 4. What is that 12 pi going to do? Shift the graph what? Left, yeah, opposite, right? Yeah, opposite. So left by 12 pi, and then that -5 is going to go 5 down, right? So yeah, so everything is a little bit opposite here as well. That b value, if I did 2 pi divided by b, I know my original period is 2 pi, but all of a sudden it's going to stretch to 8 pi. So that's how I know that it's a horizontal stretch by a factor of 4. Horizontal stretch is what your new period is versus your old period. So if I go from 2 pi to 8 pi, that means there's a horizontal stretch by a factor of 4. So basically, it's just going to be the reciprocal of whatever number you see here. Okay, any questions with number 1? Okay, again, key is attached, so if I'm moving too fast, you can always check back and look at the answer key. All right, let's look at number 2. Write a cosine function with amplitude of 2, reflection over the x-axis, period of 2 pi over 3, phase shift left pi over 2, and vertical shift up 12 units. Now, we're going to be creating our equation from scratch, so we're just naturally going to put it in this form, which means that we don't have to worry about any adjustment with the b value, okay? Because we're going to put everything in the proper place. So if we're creating an equation, we don't have to worry about making an adjustment with that number outside. Any questions with number 2? Okay, number 3. Write a sine function that completes 1/4 of its period in 3 pi. So that means when it reaches 3 pi, it's only 1/4 of the way to its period. So what does that mean? That means how long will it take then for this sine function to fulfill a full cycle? 12 pi, right? Because 1/4 is 3 pi. So I'm just 2/4, another 3 pi, another quarter is 3 pi, and the 4th quarter is 3 pi, right? So I'm only 1/4 of the way there, so I'm just going to go that same distance 3 more times. From here, we can work backwards and solve for b, just like number 2. Okay, the next part, we have to draw the graph out so that we can actually figure out the amplitude and the shift, because it doesn't quite give that information to us in a straightforward way. We know the minimum value is -7 and the maximum value is 3. Now everything is going to be symmetrical, right? So if I can figure out what is between the minimum and maximum, then that's going to be my center, right? That's going to be my midline. So I'm just going to graph it out and just count my way through and see if I can convince myself where the center of my graph is. So I know my graph is going to, cycle up and down between -7 and 3, but where's the center going to be? -2. Another way you can tell, you can just add the two numbers and divide it by 2, right? You can find the average of these two numbers. -7 plus 3 is -4. -4 divided by 2 is -2. Convince yourself also by counting, right? From the midline to the top should be the same distance from the midline to the minimum. So this is my midline. So if I know where my dotted line is, that also means I know what the value of what?
A.
Not A, but D. Yep, that's my shift, right? That D is going to take my center and it's going to shift it up by that many units. Now, how can I find my amplitude? Good. Yes, right. Count from the center to the top or count from the center to the bottom. Should be the same value. 1, 2, 3, 4, 5. Right? It doesn't specify whether there's a reflection or not, so you would earn credit if you did -5 or +5. How to get 5 again? So 5 is the amplitude, right? So amplitude, so if I can imagine a sine graph, amplitude counts from the center to the maximum, right? Remember, amplitude, we never go from minimum to maximum. We go from the center to the max. So that can be a distance of 5. If you count from the center to the bottom, it should be 5 as well. So we should be completely symmetrical between the center, the maximum, versus center to the bottom. Phase shift to the right, so we can just say our C value is -3π/4. And I think we have everything, right? We have our A, our B, our C, and our V value. No. No, you don't have to. I just like to get all my information just to show what I have. But if you jump directly to the equation, yeah, that's fine. It would be, yeah. If this is write a cosine equation, it would have all the same properties. We just replace sine with cosine. Okay, number 4. So this is a problem that we got to create the table from scratch, right? So hopefully you have enough room, but if not, you can always put it on a separate sheet. But first things first, we need to do what with the equation? Yeah, we got to get that 3 out of the way, right? Because right now that 3π/4 is not reflective of what the true phase shift is. Okay, let's talk about the adjustment here. A 3 came out. Where do I need to balance that 3 out with? Yeah, I need a 3 in the denominator, right? So a 3 up top requires a 3 in the denominator, so I can maintain balance, so that I'm not changing my overall value. -3 cosine. Okay, what does 3 pi over 12 reduce to be? Yeah, pi over 4, right? So now that pi over 4 is a lot more helpful, a lot more useful, because that's the true phase shift right there. Okay, what's the amplitude? Is it -3 or +3? Just 3. Yeah, your A value is -3, but the amplitude is always positive. I'll talk about domain and range because we haven't gone over that, but it's easy. You can just look at the graph and tell. So we'll say that for the end after the graph is in front of you. Find your interval, and you're going to keep incrementing by your interval until you reach your period. Let's see, cosine starts up. Pi -3. Adjust for your phase shift, left. You got to go, what do you do to go left? Subtract. Subtract. I'm forcing a 12 for all the denominators. So 2 12s, 4 12s, 6 12s, 8 12s. And then my phase shift is really 3 pi over 12.
Or 6 instead of 2. What did you make?
Because my period is 2 pi over 3. So my full length is going to be 2 pi over 3. But I got to increment by my interval. My interval is going to help me reach my period destination. Yes. Yeah, pi over 4. Right now I haven't reduced it, but yeah, I will reduce that for the graph. Now there's one more thing that we need to do. And what's that? Yeah, we got to do that vertical shift, right? And how do we adjust for that vertical shift? Subtract 1. Yeah. So you're going to take all your numbers on the very last row and you're going to subtract 1. These are the order pairs you're going to be graphing. To help you center your graph a little bit, I like to do a dotted line with that D value, right? That's going to be the center of my graph, and your graph should be symmetrical above and below that dotted line. That's a nice way to just make sure that you're on the right track. Now make sure that we understand that 0 is not an order pair that we're using, right? All the S values do not include 0. So make sure that, I know that we use 0 so much that we assume that it's going to be an increment and a value that we're going to be plotting a point on. But if it doesn't show up, then we're not going to use it. Okay, first order pair, negative pi over 4, negative 4. Negative pi over 12, negative 1. Pi over 12, positive 2. Pi, 3 pi over 12 or pi over 4 is at negative 1. And 5 pi over 12 back at the minimum. There's your cosine graph. It's been shifted, it's been moved, it's been reflected. Okay, final thing I haven't gone over is domain and range. Your domain for your sine and cosine function is going to be the same every time. What is that? Yep, it's going to be all real numbers every time. You're not going to have any issues with sine and cosine. It's only with the other trig functions we got to worry about domain it being different or because of vertical asymptotes. Now your range is looking at your y values and stating the lowest to the highest y value. So what's the lowest y value that you see? Okay. And what's the highest y value that you see? 2. And you're going to put brackets around your range. Okay, so we haven't quite gone over this yet, but does that make sense? Any questions there? Yeah. That's right.
Okay.
Always go from smaller to larger. Domain is always the same, and range, you're always using brackets. You're always listing out the numbers after you graph it. So you're not going to be able to tell what the range is until you see the graph in front of you. Back page. Okay, number 5. For -4 sine 5 theta minus 2 pi minus 2.5, determine the domain and range. The only thing, well, you know your domain is the same, all real numbers. The range, we don't have to rewrite it, okay? Because I know that 5 theta is out of place. That's going to affect your phase shift. But the only thing you need for your range is you want to look at your A value and you want to look at your B value. Okay. So here's a way to do a shortcut to get to the domain. And well, you know what the domain is, so you can fill that in without doing any work. The range is do this, okay? You're going to create your midline. Which is that negative 2.5. And what's your amplitude? Amplitude is 4. So how do you find amplitude if you know where the midline is? Or how would you find your max and min if you know what your amplitude is and you know where your center is? We can just do what? Just count, right? Because how far is the amplitude going to stretch above the midline? How many units? 4 units, right? Amplitude is distance from rest to crest. So from the center, just count 4 units up. So 1, 2, 3, 4. What's the highest that the graph's going to reach? 1.5. Amplitude is 4. I'm going to count 4 units down. 1, 2, 3, 4. What's the lowest that the graph is going to go? Negative what? 6.5. So you don't have to graph at all. You just have to figure out the midline and then use the amplitude to count to your max and min. So now looking at this, what is your range? Yeah. Bracket, negative 6.5 to negative 1.5. Always go from bottom to top. Oh, sorry, you're right. Positive, sorry. Positive 1.5. Yes, question. Yes. Yeah, you can do it that way. Sure. Yeah, you can list out your original table. But I just want to kind of show you a bit of a shortcut where you can graph it out and then you can count from that perspective as well. So it's up to you. Okay, number 6, state both cosine and sine function. Let's start with the easier of the two. What does that graph look more like? Cosine, right? Oh, we did this already, right? Okay, I think I pulled this from a previous review, but let's go ahead and do it just for extra practice. Okay. I put some more of these types of problems at the beginning, so that you can get some more practice in. But we'll just do this. Okay, so we know this looks like cosine, so we know if we do cosine first, there's not gonna be any phase shift. But we have to figure out the A value and the B value. Okay, so we'll do cosine first. What's the A value? 2. Is there any reflection here? No, right? The cosine is starting exactly where we want it to start. It starts at the peak. If it starts at the minimum, then we gotta worry about the reflection. Now, what's the period of this function? How long will it take to complete its full cycle? So let's back up a little bit, right? Because I know we started here, but what if we imagine that we started over here? Then how long will it take for it to get back to the starting point? 24 pi, right? Because from negative 6 pi to 0, that's a distance of 6 pi. From 0 to 18, that's 18. 18 plus 6 is 24. So, or we could follow the path of this and reach its conclusion and recognize that's 24 as well. Question?
Could you also just take 6 pi and multiply by 4? That's theory.
Yes, yeah. If you understand that from here to here, you've accomplished one interval, and the interval times 4 will get you there as well. Yeah. Okay, so period is 2 pi over b. Okay, there's no vertical shift. There's no horizontal, there's no phase shift because we chose to do the easier one first. Just the A and the B value that we have to worry about. Okay. And also the nice thing about doing the easier one first is once you get to the hard one, you can also bring the information from part A, right? You know that you're going to get the same amplitude. Maybe there's reflection going on, but if you have same amplitude, and you also have the same B value. Now, can we create a sine function that looks like this cosine function, just starting at a different place? Okay, we can, right? Where does a sine graph start? 0. And it's going to rise up to its maximum, down to the minimum. Sorry, back to the midline and down to the middle. So your goal is create the equation of the sine function, and then we'll worry about the phase shift at the end. Is there reflection for the sine function? It's exactly the way we want it to look, right? So no reflection. Is our B value going to stay the same? Yes. The question that we're asking ourselves is, where do we have to go to make that dotted line turn into the solid line? Left by 6 pi. So we'll write that down here. Left 6 pi. And how do I represent left 6 pi in the formula? Plus 6 pi. Remember, you're going from dotted to solid, not from solid to dotted. Okay, and that's where I see students make mistakes. They get their direction mixed up because they're trying to get from they're going the wrong direction, right? So remember, you're sitting at the dotted line and you're forcing that dotted line into the graph that you really want. We did B already as well, but let's just get that additional practice in. You can tell that this center is not at 0. Again, looks like cosine is the function that's given to us, so we'll start with cosine. Okay, how do I find my amplitude here? How do I find my A value? Count from center to top, right? What's that A value? 6. Is there a reflection here? No, right? That cosine graph looks exactly like the one that we expect from an original parent graph. Our period, pi, right? From peak to peak, that completes one cycle. No phase shift, so we always, if we do the easier one first, you're not going to have to deal with the phase shift. What's the D value? 2. Your D value is always where your dotted line is. Okay, the dotted line is your D value. There's no phase shift. Not for the easier one, right? Because that looks like it looks exactly like the cosine graph. So we're always gonna save the phase shift for the harder one. So we always are gonna pick the easier one to do, and then we'll work in the phase shift later for the other one. Okay. So now we can worry about the sine graph. And we create a sine graph on this same picture in the same next to the cosine. We can. So we'll make the sine graph start at 0. Rise to the peak. 0. Minimum, or quote unquote 0. Okay, that looks like the original sine graph, so I'm not going to have to do any reflection. So same A value, same B value, same D value. But where can I move that dotted line so that it can turn into that solid line? Left power 4, right? I'm going only one tick mark over, one interval, one slot to get that in place. Yep.
If we move like right, wouldn't it also be the same thing?
If I move this dotted line to the right,
So like, if we phase shift the whole thing, one interval to the right, wouldn't it also be like?
remember, we're phase shifting the dotted line into the solid line. We don't want to move the solid line, because then we're not creating the graph, right? So that's something important for us to understand, that you're never going to move the graph that you see in front of you. You're going to move the imaginary graph that you are going to put in a dotted line, and you're going to move that dotted line. So I think that's a good point, because that's a common thing that a lot of students want to do. A lot of students want to move the line, the graph they see in front of them, but we don't want to move that. If we do, then we're not creating the graph that the problem wants. So remember, you're always moving the dotted line to the solid line. Okay. So what's the phase shift? What's the phase shift going to be? We're going to move it what? Say it again. Left. Yeah. Yeah. Oh, this one, yeah, I guess I didn't need brackets because I didn't have all that stuff. I could use parentheses there. Yeah, that's fine. Okay, we have a little bit more time. Let's go to the front of the packet. See if we can try number 1. Now, number 1 and 2 are the same graph. What does that look like to you? Does it look more like the cosine or the sine? Looks like cosine. Okay, so let's do number 2 first. Because number 2 is without the phase shift. Right? We'll do the easy one first, and then we'll come back and do the one that requires more setup. Amplitude is from rest to crest, so you want to go from the center to the top. I made a mistake on the key. I said 4. Wait. Okay, I did have 3. Hold on. I thought I made a mistake on one of the. Oh, sorry. All right, yeah. So on my key, I didn't write the sine function correctly, but I did put the amplitude correct. Yeah, so if you're looking ahead at the key, I made a mistake here. It should be 3 sine and 3 cosine. So that's on the key there. Okay, so to find the b value, we got to figure out the period. So how long does it take for this graph to complete its cycle? 4 units, yeah. I'm sorry. If it doesn't look like the graph that you're trying to create. Like for this one, I know I got to do phase shift here because this didn't look like the sine graph. So I have to create an imaginary sine graph and then move that sine graph to turn it into the graph that I want. Yeah. And something else that I'm missing here. What's my d value? Underscore. So we can carry a lot of this information to number 1, same amplitude, same period. We just have to draw the sine graph, figure out that there's a phase shift to the left 1. And that's really the only thing that needs to be adjusted, because you draw the dotted graph and you're moving the dotted graph and lining it up into the solid graph. So I got a couple more practices on the back, number 3 and 4. You guys can definitely work on that on your own. But tomorrow will be your quiz. Guys, you can use a calculator if it's not graphing. If you bring a non-graphing calculator, you'll get to use it. Non-graphing calculator. But having said that, I think you do it without a calculator, but You can do it with a non-graphic calculator. Okay, come up and get your phones. Quiz tomorrow.
A little bit confused
Okay.
on the part